In today's video, I'm going to show you the journey to become a data engineer by sharing my personal experience. So personally, I come from a science background, not on the data industry. But during the time of my study and of my work, was introduced with some data, which I need to process the data using either things like Excel or a database. And then slowly I started to learn about R programming language, Python, and Linux, and slowly discovered data engineer as a career, and slowly building all the skill set necessary to get a job in the UK where I am based. So why pursue a career in data engineering? So because it is one of the key to modern business success, because it is increasingly vital in modern enterprise due to the explosive growth of data. So it is essential for managing and analyzing large data sets. For example, using modeling, designing data models for efficient data management, uh, having a data warehouse and ETL pipelines to which able to transform large scale data from various data sources, and data engineer also need to know SQL and programming to in order to deal with data, manipulate data, and move data across different areas. And also in this career, you need to learn about cloud computing, whether AWS, Azure, or GCP. It is a must to kind of know at least the fundamental of cloud computing, and also the data storage technologies like distributed storage, normal RDB, relational database systems, and also NoSQL database. So in data science, there's this data science hierarchy of needs. So in this so-called pyramids, it kind of like shows you where the data engineer as a role sits. Because before you can apply everything at the top of the pyramid, like AI, deep learning, and all sorts of A/B testing, experimentation, or ML algorithms, you must have a very strong fundamental in terms of data. So if the collection of the data, which is at the very base of the pyramid, went wrong, so everything upward will have issue, either uh, having unclean data, corrupted data, and duplicated data, all sort of things that will impact um, the reliability of the or the ML models. So data engineers actually sits on what almost the two or last three layers of this pyramid. So data engineer collects data, um, whether it's instrumentation, logging, sensors, external data, etc., and then move the data by using data pipelines and either structured or unstructured data into storage, and then use different tools to explore and transform data, capturing anomaly data, etc., and provide the data to different stakeholders like data analysts and also data scientists to apply analytics and AI or ML model training. So here in this slides, we're going to see what's the difference between the three kind of like basic roles in the data industry, which is data engineer, data analyst, and data scientist. So in data engineering, so data engineer normally needs some skills in programming, data modeling, and then their job requires to build data pipeline and also some data infrastructure in order to host, to transform and store data across different kind of like systems. And it focus on something scalability and data quality. And then for data analysts, they are doing data analysis. So the skill sets involving querying, statistical analysis of the clean data, and then they do a lot of data exploration and insights generation based on their knowledge on a particular field. And then on in terms of the job tips is they will have analytic and storytelling skills. As for data science, the skill set includes machine learnings, algorithms, statistics, etc. And then what they do is build machine learning models and experiment on data, which can use data to generate insights for the business. And then tips, it will be like try to stay on current with the ML trends, because with all the generative AI, LLM models, it is at the age of the technology. So data science is evolving very fast. So both for all three roles, the skill set and also the technology landscape are changing very fast. So a constant learning is very important to pursue a career in the data science industry. So here in this slide, I'm going to show you some data engineering technologies. So the normal data engineer doesn't need to know everything. I just list down some of the kind of common things. So the first thing is to know some programming language, including Python, Java, Scala. So Python is the go-to language for a lot of data professions. So it is a good language to start with. And then the knowledge of relational database or NoSQL database are also important, because most of the time most of the data are stored in a database. So the data engineer needs to know how to interact with the database to collect data from various sources, different database flavor, etc. And also after collecting data and all the transformation, those data needs to be written into some sort of data warehouse. So in this example, you got Snowflake, AWS Redshift, Google BigQuery, etc. So on the data warehouse, you can perform two kinds of different processing. It can either be batch processing, which executed on the particular time or periodically, or you have the streaming process where small stream of data keep constantly flowing into the system, and then you have a very different kind of system to handle this kind of ingestion. So you have technology like Kafka, Spark Streaming, and Flink. And for ETL2, which is extract, transform, load tools, you have Airflow Luigi for orchestration, AWS Glue and Azure Synapse to execute ETL pipelines. And also cloud platforms, you either use AWS, GCP, Azure, whichever you think is more interesting. You can start with any of them. So personally, I use AWS more often. And further that, you can try to understand things like containerization using technology like Docker, Kubernetes, or ECS, like Elastic Container Service in AWS. And also, not limiting to data engineering, data visualization is also important. It can either be used by an analyst, but it's good to have this kind of knowledge to be able to use Tableau or Power BI, or know how to manage both servers so that the visualization tools can be renewed and getting the latest data automatically. Right, so here are some of the focus on the data engineering skill sets. So the first one is from the left, you will need to build a data modeling. So it is to understand the design and construction of data models to meet business data management needs. So basically what you need to know is to have good conversation with the business stakeholders to understand what the stakeholder needs, and then propose a solution that caters to their needs, collect the right data, do the right transformation, and write it into a data warehouse where the stakeholders can have access to it. And then by having cloud computing knowledge, you either to be familiar with major cloud computing like AWS or Azure, so you can know how to deploy the best and most efficient architecture inside the cloud computing to cater the needs of the business. And the third one is to have data warehouse and ETL pipeline. So these are the tools that allow data engineer to handle large scale data and convert data from various sources into useful information into a data warehouse. And then also it is really important to have SQL and also programming skills. That same thing, it can help to handle large scale data, etc. And the last one is to have a deep understanding about data storage, what's the best way to store data in what format, etc. This will be a very kind of like fundamental for data engineer. So now let's go through a very quickly go through the ETL process. So ETL stands for extract, transform, load. So it is the path from data source to data warehouse. So ETL is a very crucial importance because it extract data from various sources and transform into a format suitable for analysis. Because we have the data source can be in a various structure. It could be structured data, semi-structured or unstructured things like a video. It's not like records in the database. So you will need a certain transformation to make it more easily for the easier for the analyst to analyze. Then this clean data should be loaded into some sort of data warehouse which is easily accessible for the downstream stakeholder. Okay, so that the organization can make use of it to make better decision and accurate and timely information. And designing and implementing ETL process requires a lot of different skills. So same thing, data modeling, SQL programming, and also you need to have deep understanding of cloud computing, fine tuning your data pipeline to make sure it is using it has the best performance, but at the same time not causing too much for the company, right? And also implement a lot of monitoring and logging to make sure when the data pipelines has issue or encounters any error, the data engineers will get kind of like notified and can react to it in as fast as possible. So when you create after you creating a data pipelines, the data will be processed and transformed and then put into a data warehouse. So the good thing about data warehouse in the cloud computing environment is that it's rather flexible and cloud platform provides some sort of flexible and scalable solution. So it is essential. However, it is essential to have good design and think thoroughly before you started putting data into data warehouse, so that you make sure the data warehouse is clean and then tidy for the end users to use. So a well-designed architecture is the key because it makes sure data accuracy, consistency, and and includes layers of for extraction, transform, and loading. Okay, so and most importantly, it needs to align with business need. So no matter how well you build a data warehouse, if it is not tailored or aligned to the business need, and the user can't use it together to get useful insight, then it will be considered as not a good solution, right? So a robust architecture will support better data management, analysis, and business decision making. Right. After the data warehouse, we will talk about data quality, observability, and lineage. So data quality, these three things are very crucial component for any effective data pipeline. So when you run a data pipeline, you need to make sure the data arrives in your warehouse is following a certain schema and it doesn't have any outliers or anomaly. So you need to set up your system to capture those issue if it happens. Okay. So having the quality and observability, and then you will be able to uh, use tools and techniques for monitoring them, and also visualize the data lineage. So data lineage is actually the something like on the right pictures. So basically, you have kind of like a lineage of where the data come from and what kind of process the data gone through before it arrives at its destination. So it's basically is to understand the data flows and also the dependency of the whole data pipeline. So it's essential, and it is really helpful for data engineer to troubleshoot issues, because some data lineage will also kind of like a show when a particular section went wrong. So it will help you in terms of troubleshooting. And yeah, and also it's all important to have a version control, like in data engineering, because you are using programming. So it is always good to use things like Git to do version control and track change of your data engineering workflow. Right. So either you develop on local. It is always good to have a remote repo where you can push all your work, and then you can collaborate with your with team members and track change the data pipelines for seamless project development and process. Yeah, and also in combination with CI/CD, it is also very important to deploy your data pipelines, and also keep track of the that can make use of the testing tools and also the deployments build tools to make sure the data pipeline is deployed in following the best practices, and automating builds, minimize the manual intervention. So it will ensure the high code quality and faster time to market for data products. So that's a very quick introduction for data engineering. So I hope you find it interesting. So following, I will explore more data engineering tools in like a more hands-on and practical manners. So if you like my video, please give me a thumbs up, subscribe my channel, and I'll see you in the next video. Thank you.